You may have learned about the three states of matter, solid, liquid, and a gas in a previous lesson. Did you know that there is a fourth state of matter, plasma? In this lesson, we will learn about plasma. Let's start by thinking about ice. When ice is sufficiently heated, it melts to form water. It has therefore undergone a change of state, from a solid to a liquid. Recall that in a solid, all of the particles are closely packed in a fixed position, and therefore has a fixed shape and volume. The particles in a liquid are still touching one another and are able to move around each other. Therefore, a liquid still has a fixed volume, but it takes the shape of their container. What is the change of state that occurs when water is heated to 100 degrees Celsius? Pause, think, and continue when ready. The answer is water evaporates from a liquid to a gas, in our case, water vapor. The particles in a gas are further away from one another and take the shape and volume of their container. For certain substances, if we continue to apply heat to their gaseous form, another change of state could occur. These substances can go from a gas to a state of matter called plasma. For this change of state to occur, very strong heat must be applied. When heat is sufficiently strong, the electrons are stripped from their respective atoms, creating free electrons and positive ions. Although there are both negative and positive particles, plasma is neutral overall, as there are equal amounts of oppositely charged particles. Since free electrons are present, substances in plasma form can conduct electricity. This is what separates a gas from plasma. All gases cannot conduct electricity, but plasma can. Naturally occurring plasma include lightning and the northern lights. If we were to go far beyond planet Earth, stars also exist in plasma form. In fact, stars are really just hot balls of plasma. Plasma can be found in fluorescent light bulbs and neon signs. When an electrical current is passed through the mercury vapor in fluorescent light bulbs, it heats up the gases sufficiently to strip the electrons and to create plasma. Plasma screen TVs are made possible due to this state of matter. A plasma screen is made of many thousands of tiny dots called pixels, which are made of 3 fluorescent light electrodes emitting the colors red, green, and blue. The combination of these colors can give any possible color, which is why we can see all colors on these screens. The higher the number of pixels, the higher the definition, and the images will appear sharper and more detailed.